In this video, I'm going to solve a separable equation using two methods. The formal method, the mathematical rigorous one, following all the math rules, and then I'm going to do the informal method, which is the more popular one that people tend to use more often when solving separable equations. Now let's remember that a separable equation is an equation that looks in this form. dy dx equals a function of x only times a function of y only. So if we take a look at the problem that I chose here, we have dy dx equals 2x to the 4 times e to negative 3y. So I have a function of x only and a function of y only. So let's solve using the first method, which we said is the formal method. So what do we do? Well, the very first thing, I'm just going to write the equation again. The very first thing that I'm going to do is multiply the equation with e to 3y. So basically moving e to negative 3y to the left-hand side. So we get e to 3y dy dx equals 2x to the 4th. The next thing that I'm going to do, I'm going to integrate with respect to x. So we get integral of e to 3y dy dx equals integral of 2x to the 4th dx. So everything that we did so far is mathematically correct. We multiply by a function, we are integrating with the same variable, and so on. Now, we're going to use this substitution. U equals y, and let's not forget y, it's a function of x, right? Dy dx is telling me that the independent variable is x and the dependent variable is y. So we're going to write u equals y of x. That means the differentials are du equals y prime of x dx. Or I can write du equals dy dx times dx. So basically, this whole quantity that is here highlighted in yellow, it's equal to du. So we get integral of e to 3 times y, but y it's u now, right? I'm using the substitution. Du equals integral of 2x to the 4th dx. And we can integrate now. The left-hand side is going to be e to 3u over 3. The right-hand side, and I can actually do one more step, it's indefinite integral, so we can write e plus c1. The right-hand side is 2x to the 5th over 5 plus c2. So basically, e to 3u over 3 is equal to 2x to the 5th over 5 plus c1 minus c2. So a constant minus another constant, I can just say it's some constant. Then we are going to multiply by 3, so we get e to 3u equals 6 over 5x to the 5th, and then plus 3 times c, so 3 times a constant, it's again a constant. I can apply ln to both sides, and we get 3u equals ln of 6 over 5 x to the 5th plus c. And so u equals 1 over 3 ln of, well, I can put I can assume my quantity it's positive, so 6 over 5 x to the 5th plus c. But going back to u being y of x is going to be 1 over 3 ln of absolute value of, oh sorry, it's just, I'm used to putting absolute value, but again I just assume that it's positive. So y of x is my solution in terms of x, so it's written in explicit form. Now let's take a look at this problem from the informal method. Let's see what happens informally. So I can actually write it here. So method 2, informally. Well, informally, when we start with dy dx equals 2x to the 4th e to negative 3y, the very first step that we do is we multiply by dx. So this is y, so dy equals 2x to the 4th e to negative 3y dx. So this is why this method is informally and is not mathematical rigorous, because dy dx it's a derivative, and we should not treat it as a fraction. But luckily, in this case, when we discuss separable equations, it just works. And you'll see why. If I continue by multiplying by e to 3y, I actually end up with e to 3y dy equals 2x to the 4th dx. So if we compare these two relations that I have here, or I can actually go even one step further to integrate both sides. So here I get integral of e to 3y dy, and then I get the integral of 2x to the 4th dx. Now if I compare these two equations, this one and this one, they look pretty similar, only the one in the formal method is in u, and this one is in y. But if we continue this one, we get e to 3y over 3, so we are getting the same antiderivative, and this one is equal to 2x to the 5th over 5, and then plus the constant. And if we compare now, or if we compute, let's say e to 3y equals 6 over 5x to the 5th plus a constant, and then when we apply ln, we get 3y ln of 6 over 5x to the 5th plus c. So y equals 1 over 3 ln of 6 over 5x to the 5th plus c. So when we compare these two results, this result that we got here with this result, we got exactly the same thing. So this method where it just works to multiply by dx, it's used more often because it just shows how we separate the variables to have only x's on one side and only y's on the other side. But it's good to understand the formal method, because that's the more rigorous method that you want to understand before working on the separable equations using a few tricks, basically. I hope this helps.